welcome to today's Star Wars Flip Lecture. Dun, dun, dun. Featuring Yoda. What's up, Yoda?
Hello.
Alright, so today we're going to be looking at probability distributions that are binomial. For binomial, there are two types of distributions. One can be represented by CDF and one that can be represented by PDF. PDF means when there was exactly one or exactly two events out of all the possibilities that are going to happen, and then CDF is when it's cumulative. So let's go to the board. Look at number 1. This problem, find the probability that exactly one of the family members in front of you is stopped. So we model this as 6 choose 1 because there's six family members in front of you total. Find the probability of exactly 1. Probability of finding the person is 0.3, and you raise it to the x power, which in this case is 1, times q, which is 1 minus p, to the n minus x power, which in this case 6 minus 1 is 5. So once you compute this in your calculator, you will get the probability to be 0.303. Now let's move on to number 2. This is a CDF problem. So to find the probability that more than 2 of the family members in front of you are stopped. This can be modeled. This is the equation: n choose x times p to the x times q to the n minus x. But to show my work, this is how I'm doing it. The n value is 6. X can be 3, 4, 5, or 6 because it has to be more than 2. P is 0.3 as it was in the first problem, and q is 0.7. So basically, we do this 4 times and find the sum for each x value, and that equates to 0.256.
Okay, so we group these two types of problems together because they're the same type of problems. One is binomial PDF and one is binomial CDF. And the main idea of both of these is the same as was stated before. You're just trying to find, in CDF, you're trying to find the sum of the amounts, and in PDF, you're trying to find what exactly happens. And so what we learned when the difference is to use PDF and CDF. Alright, so anyway. So for the start of number 3, special problem is 9C. It says, let x equals the number of people in front of you who are stopped. What type of random variable is x? So we said x is a discrete random variable because it can be counted. Now you may be asking yourself, what is the difference between discrete random variable and continuous random variable? Well, the difference between a discrete random variable and a continued random variable is that a discrete random variable can be counted, but a continuous random variable has to be measured, which is not written up here, but it's a nice factoid for you to remember. So, in conclusion, a discrete random variable can be counted, and a continuous random variable can be measured. Alright, so number 3 asks us, what type of variable is x? In order to do this problem, we have to know the difference between different types of variables. There are discrete variables and continuous variables. After doing this problem, you learn the difference between discrete and continuous variables so that you can continue to do these types of problems in the future. I'm Han Solo.
Go.
Okay, 4 is a number binomial problem in which we explained the numbers 1 and 2. But this one's different because you can only use 0 to 3. Because 4 is not less than 4, so you can't use it. Go.
So this is how you find the mean and the variance of a random variable. So in this case, the random variable is the amount of people in front of you that are going to get caught. And the probability of someone getting caught will be 1/7 because there's 7 total probabilities. So to find the mean, you multiply x by each probability. So 0 times 1/7, 1 times 1/7, 2 times 1/7, and so on. Then you add those up to get 3. So the mean in this case would be 3. find the variance, in other words, which is the standard deviation squared, you subtract x bar, which is the actual, no, you subtract x from x bar. So in this case, 0 minus 3, which is our x bar, which is our mean, multiplied by the probability, plus 1 minus 3, which is the x minus x bar, and so on for 0, 1, 2, 3, 4, 5, 6, and 4, 5, and 6. Then you add those all up, and the variance is 0.
What type of problem is it? Go.
Okay, so number 6 says, what is the probability that you are the first person stopped? And it said that you are traveling with 6 family members and you are the 7th person in line. So, you have to calculate what the probability that nobody is stopped in front of you and then you are the first person stopped. So what we did here, we already knew how to do this problem. We take the probability that you are not stopped and do it to the 6th power since there are 6 people in front of you, and then do 0.3 to the 1st power because that's the probability that you will be stopped on the 7th time. Now this is a basic type of probability problem that we learned how to do, and you basically learn to calculate the probability of when something doesn't happen, but when it happens to you. So like the certain number of people in line and the amount of people that you are, and the probability is that they don't get it, but you will.
This type of problem uses a histogram. Histograms and other types of graphs are important in stats, and we have to know how to analyze these types of graphs. With this histogram, we can see that this distribution is a normal distribution. It tells us about the proportion of passengers stopped by the customs for baggage inspection in this problem. There are 3 that land between point 1 and point 2, 20 that land in between point 2 and point 3, 19 that stop in between point 3 and point 4, and 8 that stop between point 4 and point 5. Normal distributions are, damn it. I should have just stopped there.
Yeah.
Alright, yeah, I'll stop it there.
Did you say what type of problem it is?
Histogram.
Alright,
Analyzing graphs.
start here. I'll trim it.
Say what we learned. What we learned. How to read graphs.
Hurry up, we're on
Say it's
camera.
a normal model.
I'll trim it.
Just say how
This type of problem is an analyzing graph problem. It teaches you how to read different types of graphs and analyze the types of information that it gives you.
We were trying to figure out the mean and standard deviation of different sample sizes. And when we increase the sample size, you can see that the standard deviation normally stays the same and the mean gets closer to what the customs workers said that the mean was. What else do I have to say? Okay, for numbers 15 to 18 in our scatter plot of standard deviation versus sample size, you can see that our standard deviations are almost all the same. And for our best fit model, it is y equals negative 1.08 times 10 to the negative 5th x plus 0.065. And in the theoretical formula for standard deviation, we found that it is 0.065, and our average standard deviation from all our trials is 0.064, so they were extremely close to the same standard deviation overall.